Yeah. Then how is it for next week? They're going to have it like
Yeah,
starting from
we
when?
don't have any updates yet.
Oh, okay. Okay. So these two question 3 you okay. Question 6, how come you cannot do find dydx? You can find dydx?
I don't know. I think so. I'm not sure if it's correct or not also.
Question 6 So hello Sarah. Question 6 dydx is you have to use the product rule to do it. So you get 1/3 2x negative 2/3 and x square minus 1 1/3 and plus 2x. Oh, there's something missing. So sorry.
Oh, yeah, I missed out something.
I also missed out something. Forgot
Okay.
about the 2. Sarah, do you do the work?
Yeah.
Do you do the work?
Yeah.
Can do or not?
But it's like I didn't know how to do I think question 6. This one.
This one. Okay.
Mm.
Yeah. Okay, first of all, get the differentiation first. So this is a differentiation. Something like that. So this is your dy dx. Yeah. Do you get something like this? I simplify a bit. Samantha, your side, very loud.
Yeah, hold on.
Huh? Yeah. You all get this? If I'm going to simplify it further, I will get something like this. I pull out all the lower power terms. Okay, I pull out all the lower power terms. I will get like this. Samantha, you did the wrong question.
Yeah, I did the wrong question. I did the first
Yeah,
one.
I thought you tried to do everything. Sarah and Angelina, you all able to get the answer, final answer like this?
My differentiation was wrong.
I couldn't really like simplify it properly, so
Okay.
Yeah.
I'm checking the steps, huh? Just hold on. I'll keep this. Oh, there's an error little bit here. This one. Then I take out one. Two. So here is one. Two. Okay. Yeah. Y'all got the differentiation here. At least this step.
yeah.
Okay. Then after that, this is the answer. If you cannot show, it's because the question should be increasing, not decrease. Yeah. So this part just be careful. It increases because why? Because when your x is more than one, okay, when your x is more than one, then you find that 6x squared minus 2 is more than 0. Then 2x negative 2 over 3 is more than 0. X squared minus 1 negative 2 third is more than 0. So everything is more than 0. So the whole thing is more than 0. dy dx is more than 0. You get it? So it is not true. So it increases, not decreases. Probably I didn't change last time. Yeah. So roughly, okay, so this is the work. Idea is to get the increasing decreasing part. Okay. Yeah. Then next one, next one we are looking at is 4063B, right? So the next one. Yeah. So for this question, we have 2 and 6. Question 2 and question 6. Yeah. Any question on this part? Now you're in set 4. Please work extra hard, okay? This is your a very big milestone to cross. Yeah, really, it's like your future will depend a lot on this year in a way lah. Okay. Of course, maybe engineer, okay lah, I can still 2 more years later. But yeah, that is a trial. 2 more years later, all of you will have the national exam again. If you're going to yeah, then it will be a very very pressurized year. So try to get used to it. Okay. Yeah, things like this you see happen, right? Like, oh, suddenly this situation doesn't allow people to go to school. Yeah, so things like that can happen. Then how big is the impact, we also don't know. Whether is it going to affect a lot on the national exam coming. Yeah, we don't know. So you have to get yourself prepared for all these moments whereby, so if you can work now, you try to work harder. so that later on anything unexpected you still can do something. Yeah. Okay. Is it okay? If okay, I will erase the board here. Yeah. So Sarah, okay. Yeah. Then this question two can do. Can
My
do.
question
Yeah.
2 was wrong.
Huh? What the
Question 6 is okay. Question 2,
cannot
couldn't
get?
get the answer.
Sarah can get the answer.
Mhm.
Question two has a stationary point at 2, 7. So the first thing we do it is the idea for question two. Sub 2, 7 because stationary point or not, the point is still on the curve. Okay, so we sub it into the curve. So we get 7 equal to 2a plus b over 4 minus 1. Can follow? Samantha also can follow. So you get 7 equal to 2a plus 1/3 b. So something like one equation. Yeah, two unknowns will need two equations. Yeah, so the next thing is to differentiate because stationary point. So we need to differentiate. So we differentiate the y. And this part, of course, you have to initiate to write it as. Don't use quotient rule if you can. Okay, just use the normal rule. Yeah, so you have negative b 2x minus 1 negative 2 and 2. So after that at 2, 7 dy dx equal to 0 stationary point. Okay, yeah, so in this case you will just let x be 2 lah. Yeah, so if you simplify a bit, this will give you 2/9 b. So after that you solve the two equations to find a and b. Okay, something like this.
Okay.
Can so I leave it to you to get it. So you get a and b. Then how to find the other stationary point? Yeah, to find it is you will get from here again. Now is without x equal to 2. Okay, you just solve it generally. So part b is 1. You already know your x a and b, so you can find your x from there. Yeah, so there will be two x values. Yeah, something like that.
Okay.
Can roughly the idea. Okay. Number 6 can do number 6, find the turning point. So use the formula for ln how to differentiate. Then use quotient rule. Yeah. Okay. The work that you all do can you all like send me a picture because I cannot see your physical copy. So you just take picture, take it properly. Don't shake your hand okay, so that I can see the images Then send it through WhatsApp. Private sending will do. Okay. Then I just look at your work. I can comment if I see anything the issue. Can? Yeah. Okay.
I
So
still can't send.
sorry.
I still can't send.
But yeah now.
Do I just like?
Oh, you ask your mom to send.
Okay.
But for Sarah, I thought school is going to close so you have to need your phone right for many things. I don't know.
Maybe I'm not sure.
You ask your mom to send or you just take the phone and send for a while Okay. Yeah. Try
Okay.
to send it through WhatsApp. I think is the easiest among all the programs because you all have it. Yeah. Have it. Okay. So the next one is CT. I tell you, I have to warn you, this differentiation topic is the big topic. So in the exam already got a lot of questions on differentiation. Okay, so try to do it well. Yeah. Okay. Y'all try this question one. Okay, this question one I think haven't tried Sarah tried.
Yeah, but I didn't get it. So
Yeah, I don't know how to get it.
The show part. Is it?
the show that AB equals to what? I
Yeah.
didn't get it.
Okay. You see, it involves the 8 and 1. They look like from the point C. So the point C plays a very important role. Okay. Then another thing is the cosine and sine. You have the cosine and sine. Then this means that probably you have to use some trigo, and we'll be thinking of right angle triangle type, Picasso that type of thing. Okay, since there's a right angle triangle there. So that is your idea lah, initial idea. So this picture first. So I draw a picture like this. I exaggerate a bit. I put the C a bit lower so that the C is here. Okay, then I will draw a line horizontally here so that I can get my theta going. Okay, I have a theta here. Okay, so this is this part here. Then of course this is theta, and AB is this part, this origin. Yeah, A to B. So A to B is obviously AC plus CB. Yeah. Now I want to find out the length. To find out the length, maybe I start from this triangle. This triangle. How long is here? Are you able to find out this length?
Yes.
How long?
Isn't it like B minus 8 or something?
You see, just for a while, the issue is this.
Using trigo?
Yeah, by right, okay, by right is this, so I write in blue. Don't copy first. You need to go through some ideas and then see whether it works or not. So in this case, I take out the triangle, and then this is B minus 8, and this is my theta. I need to find this length. So under normal circumstances, this is very natural. I can say that is sine. Hypotenuse, right? So your H is this length. For example, okay. But the question is that they don't have A and B. They don't have the B in the question. There's no B. No B. Then if it's no B, then how do we get the length without a B? Okay, so this is an approach that may not work that well. So if you really want to use this method, then you need to be careful how to use it. Okay. Yeah. Then what other ways to do it?
Tangent theta equals to
Tangent is not very good. Tangent not very good because there's no tangent in the equation. So
okay.
tangent will become a bit troublesome if you do the conversion and so on. Okay. Instead, we use the 1. You see, the small triangle, the 1 will actually avoid the B. Okay, we avoid the side here. Okay, so we use the 1. So we are trying to choose the side that allows us to find the length EC without going through the B. Yeah, so we have the length BC. Yeah, so you have the triangle here. Yeah, can you find the BC? We'll be using cosine. A over H or CB. Can? Cosine theta is 1 over CB. So in this case, your CB is 1 over cosine theta. Which is this term? This must be your CB. Okay? Can, yeah, so we try to avoid the B, even though it's correct, but the B being present will make a very big challenge to us. Yeah. So the next one, how about AC? How to find AC? Probably, I don't know, get a triangle. Okay, get this triangle. Why not the big one? The big one has issue because if it's a big triangle, you involve the B, and then here also not sure. Or is it A? Yeah, A. Then both are A and B. You try to avoid them. Okay, so we use this triangle. Okay, use this triangle. Then what happen? You'll find that this triangle, if you take it out, A to C, theta. Then you'll find that I will use the length. Where's the length? Where are you? Wait, what's the length here? 8.
Mm.
Okay, because it's the height of the point C, 8. So we use sine. Okay, so you get the length of AC from there. Yeah, so these questions tell us that we need to get the right expression, the right type of figures, then you can get the right result. Okay, Samantha, you okay? Can yeah, because it's an online thing, therefore whatever you all do, right, will have to be a bit animated, because you all look very small to me, therefore you need to like nod your head, then I can see properly and so on. Yeah, in contrast to, yes, Samantha, yeah, you got it. Later your neck twisted yeah. Okay, can Sarah? So this
Yeah.
part is done so we get this part. So after that, find the least value of AB. How to find? Differentiation. And always remember when you have this value or maximum value, this sort of question usually belong to differentiation. Almost all the time, differentiation. This value, largest value, maximum value, greatest value. Okay, so we do differentiation. Easier if you let it be L, let's say, then L equal to secant theta plus 8 cosecant theta, for example. Then we do differentiation. Then remember, the above average people know how to differentiate secant theta and cosecant theta. So I don't know whether you're above average or not. So secant theta differentiate is this. If you don't know, don't worry. You just use the cosine theta power 1 and differentiate. Also can. Okay, but it will be good to remember it'll be good if you can remember. Then the next one, cosecant differentiate is negative cosecant cotangent. Then for this value or greatest value, we always let it be 0. Let DLT theta be 0, then you get you'll get this equation. But how to solve this equation? It's a trigo equation. It turns out it's a trigo thing. Yeah, then this is your trigo business already. Then how to solve it? You have to think about how do I get the situation to be better. Okay, first we go through a bit of trigo stuff. When you have all the angles the same, that means you can throw away your double angle formula. You can throw away your addition formula. Okay. So what can we do? You'll find that not much you can do now, except you can improve the situation by writing all these secant and cosecant cotangent into their natural form, their basic form. Then you're more familiar with the terms. Okay, so we write it in that way. like that. But writing in this way also has a problem because we don't know what formulas to use. Then to improve further, you change your tangent to sine over cosine. Can you see the 2 there? Okay, then minus 8, then change that part, you'll get cosine theta flips out, and the bottom becomes sine square. Okay, so the thing to learn here is that when you solve trigo equations, we look at the angles. Are the angles the same or not the same? So that can we use double angle formula or we use addition formula? If they are not, if they are all the same in this case, then you just have to up your chance by changing them to familiar forms. And here we change the secant to cosecant, to cosine, 1 over cosine. Then at some point of time you'll find that the tangent is quite far, like not related to cosine and sine, so we try to change it to sine and cosine, so everything will be sine and cosine. Then you'll increase your chance of getting right. So that is the solving now. Okay, then after that, how to solve this equation? Normally to solve this equation, you can easily think of it as put them into one fraction. Okay, put into one fraction, you'll see a sine cube theta minus 8 cosine cube theta divided by the denominator equal to 0. So far, okay, huh? Okay, if okay, I will continue on the other side. Then this means only the top is 0. Only the top is 0. But how to solve the equation? Yeah, we always have to think about how do I solve the equation? How do I solve the equation? When I change to another step, how do I solve the equation? You have to think of that all the time. So how to solve this equation?
Is it our formula?
Probably no formula.
No.
Because got power 3. Power 3, we don't have formulas for trigo power 3. Yeah. Okay. It's not easy. I tell you, I give this sort of question to special group of students who are high ability. They also, some of them, cannot, and forgot. Okay, it's actually, because here is 0, right? There's a special way to do it. If I write in this way, are you able to see? Then I divide throughout by cosine cube.
Oh.
Okay, remember this method is quite special. Sometimes you see this method. Is that because sine over cosine is tangent, so we can allow to divide and get a tangent. Then I can get a nice number like 2. Okay. Yeah. Then after that, what to do? Are you able to solve already? Can you all solve it and see? What am I doing now? Cannot. Able to solve? Yeah. What the question is asking is you have to go and find the least value, right? Okay. So how to find the least value? Without the use of calculator.
Oh,
Yeah, without the calculator. That's the hard part. How to use without the calculator to solve it. Okay, I will erase this part a bit. I erase, sorry. I something wrong with the cannot delete. Okay. I write here. So your tangent theta equal to 2. Okay. Now I need to do something before I can move on. Is that this? Tangent inverse 2. What am I doing here is I want to find out whether is it a minimum. Do you remember? I have to find out whether is it a minimum. Check. Okay. Do you remember the first derivative test? First derivative test, second derivative test. So the first one is this one. Draw the table, right? Second is you find the second derivative. Okay. So which method will we use here? Yeah, which method to use here? So it depends on your differentiation expression. Is it difficult to differentiate again? Yeah, it's your judgment. If it's difficult to differentiate one more time, then you'll stick to the first derivative. If it's easy to differentiate one more time, we will always do the second derivative. Okay? Yeah. So here in this case, I myself feel it's quite difficult to differentiate. It's product rule of all these are unknown terms, right? So it's not so easy. Okay? So I will do the first derivative test. Okay? Yeah. So I'm going to do the table. So I have the table. Shape. Then I draw 3 columns. Then here is let's say this number is A. This whole thing is A. So I write A here. Here I write A plus. Here I write A minus. Then because we have found that the value of A makes the DLT theta equal to 0, so the center here is always 0. If it's not 0, then you have to step yourself because you have solved wrongly. Okay, so it must be 0, and the shape is horizontal. Then after that, what is A plus? A plus is you need to find out this number, and this number tangent inverse 2, you have to put in radian. Make sure it's in radian. Then what is the value if it's tangent inverse 2? Okay, you'll get 1.107, for example, around there. So your A plus means you're going to use a value of 1.2, let's say 1.2. Okay, a little bit more.
I thought can I use calculator?
This is cheating lah. Cheating.
Okay.
Okay, cheating lah. Yeah. So here will be 1.2. Then you press for the I show you the without calculator method lah. Okay. Yeah. So we just here to get through this part. So 1.2, where do we sub in? We sub in here. Sub the 1.2 into the DLD theta. Then to check the value, is it a maximum or minimum? Okay, so in this case, just to cut short things, this will be positive. This is negative. Why? How I know? How I know? I actually work backwards lah. How do I know? Because the question asking about the list. This means minimum, right? So I can work backwards and fill out the table. Yeah, so I tell you, in exam, a lot of people use first derivative test because they know they can get away from it. Okay? Because they can anticipate the table, how the table will be filled out. You get me? But this method, without calculating the values, works if you have only one answer. You get the point? If there's only one answer, then the answer must be the answer in the question. But if the working has two or more answers, then you better check properly. You get me? We don't know which is the correct answer, so you have to check. Yeah, can then from here we say that minimum. Therefore, this value of AB is equal to, what is it equal to? Is this expression, right? This expression. I'm going to erase certain thing. I'm going to erase this part. Okay? Not easy because without calculator, how to find secant theta from tangent theta? Remember in trigo, we learned something about conversion between trigo, sine, cosine, all these things. So whenever you have a question, okay, getting values between different trigo terms, use the triangle method. Okay, use this triangle method. So this triangle method is a very good method to convert between sine to cosine, cosine to tangent, and so on, etc. So based on this result, right, tangent theta is 2. This means 2, 1. You get me? 2, 1. So if it's 2, 1, then what is the hypotenuse length? The hypotenuse length is root 5, right?
Yeah.
2 square plus 1 square square root. So it's root 5. So in this case, we have cosine theta. Once you get the length of the triangle, you can find all the trigo terms you want. So you get 1 over root 5. Sine theta gets you 2 over root 5. Understand? Samantha also? Yeah. So here, our length is secant theta plus 8 cosecant theta. So you can easily see this is 1 over root 5 for the cosine plus the 8 cosecant is 1 over sine. Okay, so if you do the manipulation, the first term will get you root 5, the second term will get you 8 root 5 over 2. You flip the fraction. Then 8 over 2 is 4, so altogether is 5 root 5. Okay. Can this question is not easy. Yeah. I just want to show you I going through the expression, going through the table which is a bit dodgy here.
Dodgy.
Oh, okay, shouldn't use dodgy. Suspicious. I don't know. Okay. The reason is because we shouldn't be using calculator lah. Okay. Yeah. But the question asking without calculator is actually they don't want you to use calculator fully to do the problem lah. Okay. So just take note of that. Yeah. So so this question any question? We talk about trigo differentiation is to because I want to revise trigo with you. So just revise trigo lah. Yeah. Okay. If okay, we go back.
Okay.
Has your school finished differentiation actually?
No.
Not yet.
Engineer no, Sarah not yet also so long. So you can see the journey is very long differentiation is really horrible. Sarah, your school finished no, Samantha.
No, haven't yet.
Have you started already, right?
Yeah, started already.
Okay. Okay, let's go through the next part first. Then homework I will assign in the WhatsApp group, okay? No, maybe not. Sarah will have problem. Okay, homework first. Copy along the way. Okay, because Sarah doesn't have the phone. So homework here. I just give you 2 questions. I don't know next week how your school is going to show you all the homework. I don't know. So I will just give you 2 questions. Okay. First question is question 4. Okay. Later on then we have another one. Okay. We go to the next section on rate of change. You all have the notes, all of you. Samantha have the notes.
Wait, I need to find.
Go and find, please.
I don't think I have.
Y'all don't have
I don't think I have. Yeah.
Oh, good. I think I have to just show you here, then I will WhatsApp you. Okay.
I can't find my notes there.
Yeah, I know. That's good. That's why I'm asking you all where is the notes. Okay. Wait for me. I WhatsApp you.
Okay, I go get water, Archer.
Can. Okay, I sent you the soft copy already in the WhatsApp group. This soft copy is the condensed copy. That means I left out all the blanks. Okay, so if you want to print, if you can print, but I discourage you all to print. We are already doing a lot of things, and now we are getting into this situation the mankind, right? Yeah. So if you can just keep it as a soft copy. Then if you really want to print, you just go ahead. There are 3 pages, I think. Yeah. So
Can you
yes.
give it to us?
What's that?
I don't think.
In the WhatsApp?
Oh.
But like you didn't give us hard copy, right?
No, I think no.
Oh.
Because
Yeah, okay.
when I wanted to the school closed already. Yeah.
Okay.
The center closed already, I mean. Yeah. Okay. I sent to you already. It looks something like this. It looks something like this. It's a condensed version. So you can see all the examples, the spaces between them all cut away. So I will do that in the future lah. Okay, so you all won't have to read so many things. I mean, print so many things if you want to print. Okay, so we look at this last chapter on rate of change. For engineer, this may not be your last session, depending on your school. Okay, because your school using your graphing calculator, so they may go a bit further in. Okay, but it will be good enough. Okay, for the moment. Yeah, the last session is rate of change. Rate of change. Don't need to read the first paragraph lah. Okay, it's just a bit naggy. Okay, main thing is here. In differentiation, the quantity dy dt is interpreted as the rate of change of y with respect to t, right? Can? Yeah, this is the English way of saying dy dt. Then, in particular, if t represents the time, right, we can simply call the quantity dy dt as the rate of change of y. Don't need to say with respect to time because it's understood. Get it? So when you read question, when the question says rate of change of y, then you know that is dy over d time. Okay, with respect to time. Yeah, not any other thing. Yeah, but if you see a quantity dy dx, you need to tell people this is rate of change of y with respect to x. You must tell people. Okay, you don't say rate of change of y full stop because it's not time. X is not the time. Then you have to tell completely. Okay, so let's look at this example 23 now. If you have a problem like notes all these things, then let me know. Okay, I see whether how I can arrange. Maybe can post or what, I don't know okay, then yeah. Okay, so here we look at this example. Can see I make it smaller. Yeah, example 23. Yeah, the radius r of a spherical balloon at time t seconds is given by this formula. Yeah, so the radius is connected to time by this formula. What is the initial radius? And find the rate of change of r when t equal to 3. Okay, the keyword here is rate of change, the rate. When you see questions like rate of change, rate of something, this is the topic, this is the session. Okay, yeah, so copy down the homework already. Later I put in the WhatsApp group. Yeah, so this one example 23. From now onwards, you have to use your full scale paper or print paper, whatever. Okay, then here is the formula. Yeah, there are two questions here. First question is initial time. If you take science, right, you'll know that initial means t equal to 0. Okay, we put t equal to 0, r equal to, very simple, 5 cm. Okay, initial radius is 5 cm. Get it? Yeah, so it's a very simple question here. Then next part, find the rate of change of r when t equal to 3. You have to understand that in general, how the r changes depends on the time. Okay, yeah, so that's why they say when t equal to 3. Okay, let's do a differentiation. Because rate of change of r is dr over dt, right? dr over dt is the rate of change of r. I don't need to say with respect to time. It's understood. So rate of change of r is 0. Then here we may want to prepare ourselves if we are not familiar. This is power negative 1. Then I just differentiate it. If you don't use chain rule, it's best. Quotient rule. If you can drop product rule, quotient rule, it's better in general. Yeah, so you have this part and then you get okay. Yeah, so what is this? This is called the general rate. general rate of change of error. Okay, then general is because it's a formula for finding the rate of change, but in this case they want t equal to 3, so we sub in t equal to 3. Then this is your specific rate. It's specific only at the time equal to 3 seconds or 3 minutes, 3 seconds. Yeah, we just put in. Okay, so this quantity gives you 4. So the rate is with the units second is decreasing rate. The negative means decreasing rate. That means the balloon is deflating. Okay, yeah. So positive means increasing, negative means decreasing. Can all the three of you? Can Okay, let's look at example 24. I'm going to erase it. Can you erase?
Wait.
Okay.
Okay.
Okay, thanks. Example 24. The question, the volume of water V in a leaking tank at time t seconds is given by this formula again. There's a formula for time between 0 and 15. Find the rate. So again, the key phrase is the rate. Okay, yeah, and then the water leaves the tank at this time. So it's a rate of change problem. So we do the differentiation. So we have the V is the water quantity. Then we find the rate, the general rate first. So we do the differentiation. Simplify a bit. Okay. Now is this is the general. We want the specific one at t equal to 4. So we sub t equal to 4. So this gives you a negative number of negative 363. Negative means the rate is decreasing. The volume is getting smaller. Okay. So in this case the rate at which water leaves, okay, is positive 363. Because the question specifies leaving, the water is leaving, so the volume is already, is to tell you they just want the size of the rate. Okay, so the rate in this case will drop the negative sign. So be careful of the questions phrasing. If the word leaves is not there, then the rate at which water I don't know how they put it okay, the rate will be just negative 363. Okay, if without any description. Yeah, get it? So this is example 24. Yeah, okay. Example 25. We look at example 25. We go from simple question to more difficult question. So you'll find, oh, exam this sort of question like that. Wow, good. No, exam question won't be like this. Exam question will be more like later I will tell you. Okay. Example 25. Look at example 25. Yeah, example 25. It says this. X and Y are connected by the equation, so it's a trigo. Yeah, trigo. You all love trigo. X is between 0 and power 2. X is increasing at this rate. This is the rate because it's per something per second. X is the angle, so it's radian per second. Find the rate of change of Y with respect to time. Sometimes they will say with respect to time. Sometimes they will just say find the rate of change of Y. Okay, so it's optional for the respect to time. So this is an exam question, exam typical question. Yeah, the exam standard. Okay, how do we do it? First is this: you have to find this quantity. Okay, you have to find this quantity, but the problem is our equation doesn't have a time. You get me? I cannot differentiate with respect to time. Okay, yeah. So what are we going to do? So what we are going to do is we have to form a chain rule. Rate of change problems, they are very closely related to chain rule. Okay, so when you do rate of change problem, think of chain rule. Chain rule is the main method to do this sort of problem. Chain rule. Okay, what chain rule are we forming? Okay, we'll start from the equation. The equation is y and x, so we have dy over dx. We are definitely going to go through dy dx. We are going to find some differentiation stuff. Okay, dy dx. Then this dy dx will be equal to dy over dx. Okay, where we are going to insert in, because it's a chain rule. Chain rule is always breaking the dy dx into something else. So into two parties. So dy over dt because of the dt. So we are trying to bring in the dt in this way. Okay. Yeah, but the chain rule can be formed another way. The other way is this. You see, dy over dt times what? Wait.
Why not just do dy over dt equals to dy over dx times dx over dt?
This one. This one. No.
No, dy over dx.
Yeah. I write again. Sorry. Yeah, write again. Okay, we have this part here. Okay, so there are two ways to write the chain rule. So first way or second way? Yeah, thanks. Okay, first way or second way? So in this case, which way is the way for the question? So there are two ways to form a chain rule. I go through one more time. You see your dy dx. The dy dx is from the formula here, so we can get dy dx. And this dy dx will be made either the subject or as the non-subject. Okay, here is the subject, here's the non-subject. Here's the subject, here's the non-subject. So the subject, in this case, you have to break your dy dx into two components, and then you insert in the dt. But in this case, it's not a very good formula here. Why? This one is not very good. This one is better. Okay, the reason is because dx dt appears more natural here. Dt dx is not so natural. Okay, what is dx dt? Dx dt is the rate of change of x, right? It's more natural. Okay, but what is dt dx? We don't know. What is that thing? is the rate of change of time, a bit strange. Okay, so this part will become not very useful. So we will use the second option. Okay. We'll see this sort of question all the time. So there is always going to be two options. You have to choose the correct option to do the problem. So we are going to choose the second option. So now we are going to find dy dx. Okay, from the chain rule, find the components in the chain rule that you created. Then after that, put them together. Okay, dy dx from the formula, you get 2 cosine x minus power 6 power 1. Then after that, negative sine x minus power over 6. And follow the power, then the trigo differentiation. The angle, actually there's a angle to differentiate by 1, so it doesn't matter. So you get this negative 4 cosine x minus power over 6 sine x minus power over 6. This is my dy dx. So dy dx is done. We have completed this part. Okay, we have found dy dx. What is dx dt? dx dt is given in the question. The question says dx dt is increasing, so it's 0.3 positive. Okay, so this is your dx dt. This means that we have found dx dt as well from the question. Therefore, we can find dy dt, our main question. So dy dt, I write here, is at x equal to power 3. Power 3. So dy dt is dy dx times dx dt. So this is your negative 4 cosine x minus power 6 sine x minus power over 6 then times 0.3 given in the question. Okay, but this is the general rate. Again, it's a general because the x is there. So now we sub in x equal to how much again? Power 3. This will give us the specific rate that we have. So we have dy dt, then negative 4 cosine 0.3. I bring the 0.3 there. Then cosine pi over 3 minus pi over 6. So we get pi over 6. Yeah, after that, your special angles, cosine pi over 6 is how much? Root 3 over 2. Sine pi over 6 is half. So you can easily calculate from that. If you need as an answer, you can give them as an answer. Okay? Yeah, can. So this gives you you press calculator is 0.6, so it's negative 3/5. Okay. Yeah, then we are done. Here we'll keep the negative sign. because they never say increasing or decreasing and so on. Okay, so this is cm per second. Not cm, unit per second. Yeah, just unit. Yeah, question on this? Can I show you the question again? So this is the question. Yeah, we look at example 26. Can all of you can follow or not? The three of you. I let you see the question here. Yeah. Okay. Look at example 26. So this is a question on rate of change. So example 26, we see what is happening here. Okay. The surface area of a sphere is decreasing at this rate. Find the rate at which the radius is decreasing. So we try to capture the information the question wants us to find. Okay, you have to find this quantity dr dt. What are you given? Given a very special rate, the rate is that is area, surface area of the sphere, negative. Because it's decreasing. So when it's decreasing, you need to be sensitive. The rate is a negative number to tell us it's decreasing. So now, back to the drawing board, we have to form the chain rule. I'm trying to show you the system now, how to do it. Okay, form the chain rule. So there are two types of chain rule to form. One is this. Can follow? Can follow. But this chain rule is not very good. You have to identify the chain rule earlier so that you can don't waste effort. This is not very good. The reason is because dRdA is not very natural. Normally, it's the surface area equal to the radius, the type of thing. Then we differentiate the surface area. But this one is like your surface area is at the bottom, so it's not a very good chain rule. So the other chain rule we are going to form is involving dRdt. Okay, but this time around we have to make it the non-subject. You see, the three guys are all there almost. The two of them that are natural will be there. The one not natural, you try to do something to it. What are we going to do? We are trying to throw this to the left side. If it doesn't appear on the right side to be good, it will be good on the left side. Okay, one more time. If your derivative term appears no good, then you have to bring it to the other side. Okay, when you bring it to the other side, do you see what's the change? Some people observe something. They find, next time I can do this sort of thing. It works like a fraction. You see, it works like a fraction. When you bring it to the other side, when you bring this term to the other side, it changes, it flips over. You see, it flips over. Yeah. So for example, dy dx is dy dt times dt dx, for example. Then I find, this term I don't like. I throw it over. If I throw it over, it become dx dt. I flip. Get it? Is it okay? So what I'm trying to say is, you can just anyhow form a chain rule. Then if you don't feel like the chain rule is working, you throw the non-working term to the other side by doing a flipping. Then you'll always get the correct chain rule to do it. Okay?
Okay.
So we continue. So our chain rule is okay, we are going to use this chain rule. And now is we have this quantity. Yeah, but we need to find this quantity. Okay, we're going to find this quantity DADR. Yeah, so you need to know a bit of what is the area, surface area of a sphere. Of a sphere is how much? What's the surface area formula? If you can't remember, it's in the formula list. Formula list, you should find it. 4 pi r squared. Then in this case, we do the DADR. You get 8 pi r. Okay. Then now, after you have done that, then we can go back to the chain rule. Sorry. Times 8 pi r equal to -3. We are going to throw all the things that we know into the chain rule. So you have this part, but this is a general rate. Okay, so we need to put in r equal to 3 to find the specific rate at that instant. Get it? And what's the answer? What should be the answer? The answer should be Samantha. What should be the answer?
Isn't it the answer there already?
No, it's not. This answer is wrong.
Huh?
The answer is wrong. It should be 1 over 8 pi.
Oh, it's just.
Is it okay? Because of the word decreasing. They already say it's decreasing. So you are just reporting the size of the rate. So it's 1 over 8 pi. You don't say decreasing at a negative rate. Then it means increasing. Okay? So when there's a negative sign, it's already a decreasing rate. But because the question says it's decreasing, your reporting is 1 over 8 pi. Okay? Is that okay? Yeah. So you must read the question. See whether the question asks for the direct rate or the decreasing rate or whatever. Recap. Yeah. No question, No question, then we will do a question here. Then we'll end this chapter. Okay, the chapter is ended after one question here. So let's do this question.
Let's have a break.
Then we do the question. Okay. Have a break. Then we do the question.
Okay,
Yeah.
thanks.
You can see the question. Engineer, you're here. You should ask Phoebe to come join you. You got ask her or not? You ask engineer to join? Phoebe to join engineer.
What?
Ask Phoebe to join lesson.
I know I got.
Oh, you got lah. Oh,
Yeah.
ask her to join. Yeah. Okay. You all read the question 6. Can read or not? Sarah, you can read. Oh, Samantha, you're here. Oh, you have been always here. Okay. Example 6. A cylindrical jar, radius 4 cm, contains water to a depth of 1 cm. The water is then poured at a steady rate into a hemispheric bowl. So after 3 seconds, the depth of the water in the bowl is this amount, xcm, and the volume is V. And that has been transferred is given by this volume expression formula. So they say all the water is transferred in 10 seconds from the cylindrical jar to the bowl. Find the rate at which x is increasing when s equal to 2. Can read
Physics.
Like physics Oh. Okay. What topic? Like physics. Volume.
The rate stuff is related to kinematics.
Oh, I forgot a lot of the physics stuff. Okay. Yeah. Now we capture some of the things that they ask. Okay. One is find. We're going to find the rate at which x is increasing. So it's find dx dt. This formula tells us you probably have to find this quantity. Get it? Yeah, so something like that. Better don't highlight so much. Okay. Yeah. So so there'll be all the main participants dx dt, dv dx. So we are going to form a chain rule. So what chain rule to find or to form? Okay. I anyhow form dv dx is equal to dv dt and dt dx. Samantha, you know why the chain rule is formed this way? You okay?
Yeah, could cancel.
Yeah, they cancel off. So the dv dx is being split into 2. Yeah. So now you find that I don't know whether how you feel it. Do you feel this rate is a bit strange? Actually, it's very strange because we are supposed to find dx dt. So they're different. So I'm going to throw this over because I formed the chain rule wrongly. So I throw it over. Then it will become dv dx. And I flip it. When you flip, you'll see the terms are in alignment. If you don't flip, you'll have problem. Okay? Yeah, so do you see the cancellation again, getting you back to dv dt? Yeah. So that's our chain rule to work on. So now we have to find this quantity. Yeah, so this quantity is differentiate the expression for b. Okay, here of course we can do product rule, no problem. We can demonstrate we are very good in product rule. Okay, but normally, as I said earlier, we will try to avoid all these rules if we can avoid okay. Why because generally doing simple things is simpler. So we expand out the terms. Okay, we expand out the terms, then we do differentiation. Yeah, so we are done with this part of the differentiation. So we settle this guy. This one done already. The dxdt is this is the question. So this is the last quantity to find. So we are going to find dvdt. What is our dvdt? Okay, if you read the question, this question is quite tricky, and this is typical, also a typical exam question. Okay, quite tricky. Because they never give you the dvdt directly, they describe to you. Where they describe here. Given that all the water is transferred in 10 seconds, so if I know the volume of the water, I just divide by 10, I will get the rate. You get me? If you transfer in 10 seconds, that means you get the volume divided by the time, you get the rate of the volume. Okay, so here we're going to find v. How much is the volume of water we have? It's from here. Okay, this part tells us how much volume we have for the water. So here we talk about it, volume of water. Okay, so for volume of water, we draw a cylinder just to get things right. So we have a cylinder, the radius is 4, and the depth of water is 5. So from here we can see the volume of the water is given by pi r square h, which is just pi 4 square h. So this gives us 80 pi in cm cube. Okay, so we are done with this part. Volume. Then now we differentiate. Not differentiate, sorry. What's the volume? What's the rate again? It's 80 pi.
Volume divided by time.
Yeah. Why in this way? Why do we just divide in a simple way, not doing differentiation? Because the second statement tells us the water is poured at a steady rate. Steady rate means it's always the same. So we just use the simple volume divided by the time. Get it so far? Yeah, okay. Then now we have this quantity as well. Okay, so we have these two quantities. We go back to the chain rule and then we find this guy. Okay, so we are going to sub all these things into the chain rule. So do you see the chain rule is the main operational line, the main step that everything will go back to the chain rule. Okay, so this is what we are doing. So we have from the chain rule, dv dx is 12 pi x minus pi x squared dx dt equal to dv dt 8 pi, all from here. Can Then after that we have the dx dt. Yeah. Then after that, this is the general rate. Then to find the specific one, we throw the x equal to 2 inside. So we sub in 2.
Can you take out the pi?
Can. We can do all the cancellation and so on. Yeah. And then we can sub in also. Okay? You can do it together lah. Or you want to cancel also can. You want to cancel. Then after that you start in. Then you calculate. Do you see? Will you get 0.4? Then you try. Okay? You get 0.4? If you're okay, right? This is the second piece of homework I'm going to give you.
Okay.
Homework, Sarah, if you don't have the soft copy, then you may take a screenshot or what, I don't know. Try to get a copy from your mom now, okay? This is
Okay.
4063. This one. Okay, write out, then later on you all try to find the question and do.
Okay.
Okay? Yeah, 2 questions. So we are done with this chapter in a way. You need to do a lot of practices. If you want to be good in this chapter, you need to really do the questions. There are a lot of questions for you to do. Okay? Very interesting. Like 11, very interesting swimming pool. You know, the water going up, down. Yeah. Yeah. The interesting part is this part. It's different. So it's interesting. Okay? Yeah. Can? So I close this chapter. No more already.
Okay.
Then what are we going to do now?
The opposite.
Yeah, we're going to do this chapter. Okay, I'm going to send your WhatsApp. So there are 2 files I'm going to send you. So the other one is this file. I go to the sending first. I send to you all first. Okay, I just send it out, so you can check. It's a condensed version again, I think. Yeah. 6 pages. But if you can, don't print. Okay, you can read from there. Okay, this one. Okay, we start. Integration. Integration is the reverse process of differentiation. Okay, it's a reverse process. Yeah. If we differentiate fx, we obtain f prime x, right? Okay. For example, this is the notation now. So I write here. You get f prime. Okay. Then if you want to go backwards, then I will do something to f prime. Then I get fx. Okay. So this is the reverse of the differentiation. But it's not 100%. There's something else. Just like when you travel to and fro your house to your school, you'll find that the reverse direction is always a little bit different. Okay, so for integration, even though it's reverse, it's not 100%. There's 99% true, 1% not very true. Okay, so we are going to find out this part. Okay, first thing, do you okay with the notation? Differentiation. Okay, right here. Differentiation, we use this quantity. Sorry, I use a different that thing. Okay, differentiation, we use this quantity to tell people differentiation. Okay, If you are doing integration, then you have to use this quantity, this expression. Okay, that's the symbol. Everyone will be using that. Okay, let's look at example 1. Example 1, 1a. Let's discuss together. If your dy dx is 7, what is your y? What is your y? When you differentiate something, how can you get 7? What you differentiate to get 7? That's the what?
7x.
Oh, very good, 7x. Do you get it? You can check easily. Differentiate 7x is 7. Yeah, get it? So no formula. It's just reverse process only. Okay? This is A. B. What do you get if you differentiate y to get 4x cubed? What is the y that will get you 4x cubed when you differentiate it? Yeah, then you have to go through some differentiation. Yeah, that's the natural reaction. It's either we have to think about, imagine what is the y, then we do the differentiation, right? Do you get it? Then in your head, you have to imagine something, you differentiate, you try to hit 4x cubed. So you can think of this quantity, x4, right? You differentiate, you get 4x cubed. Okay. Is it difficult? A bit difficult, right? A bit like, wow,
Yeah.
imagine what is the y, and I don't have things to help me, that type of thing. I need to imagine. If I get it, I get it. If I don't, I need to think about it. I write it in this way, x negative 2. Is it easier? Then what is my y? Okay, how do I know? Is that I know that when I do differentiation, my power always decrease by 1. So I should have a power -1 in the first place, right? Because after that, my power will become -2. But now, imagine if my y is this term, if I differentiate, I get -1 times x to the power -2. It's not exactly. So I need to put an extra negative so that I can get positive x power -2. Okay? Imagine if I differentiate, my power bring down will cancel the negative away. So I get positive power.
Oh,
I
okay.
get positive number. Samantha, okay? Why you into the wall? Wow, like giving up. Okay. Okay, but this is not the complete picture. Okay, we look at this is just an example. Casual. Okay, casual example. Just to get a feel of what is universe. And it's not very simple. Okay. Now, for example, if I say what is my y?
Cosine, negative cosine.
Then you differentiate, you get sine, something like that. But it takes a while, right? It takes a bit of time to think about what is that thing. Not like differentiation, straight away your rule, product rule, quotient rule, all this come in. Okay, so integration is a bit more difficult. Okay, but of course you'll find that, oh, am I going to learn like this? Then no, of course there's a system to it. Okay, now we look at section 2, indefinite integral. What is that? The result of differentiation is known as the derivative. Okay, the result of integration is known as integral. Yeah, don't worry. If you see terms like integral, integration, that means you have to do integration. Okay, so the English is not going to trouble us. Okay, so let's look at this. Differentiate y, you get dy dx, right? So x squared is 2x. Okay, then if it's dy dx is 2x, what is your y? From here you can see x squared. Okay, but that's not the correct answer actually. The answer is actually plus c, where c is a constant. Why? Because when you differentiate x squared plus c, your c is gone. You get 2x, your c is gone. Get me? So if you say it's x squared, it's not completely correct because it's not the most general. Okay, in the first place, we also don't know what is y. So by putting y equal to x squared plus c, it will be able to cover every single thing. You get me? Samantha? Okay, I write here just to summarize. That's why I say it's not 100%. Okay, I summarize here. So something like this. Sorry, I write one more time. Y equal to x squared dy dx become very simple 2x. Okay, but now if I do the 2x, I reverse the process, then I will get x squared but plus c. Can so there's a difference between them. Oh, you may ask how do I get this? Okay, if I write it more slowly, it will be this. Shall I just write it? I write it below. I write it below. Okay, how do I get it? Is this one. From here, I do integration. Okay, an equation can be done with many things on both sides as long as you do the same thing. Okay, so you can do a differentiation, you can do squaring, you can do whatever you want to do. You can flip it, but provided you do the same for both sides. So when you do the integration using this symbol, you're actually reversing the process. So you're actually getting y here, because differentiate dy dx, you integrate, it becomes y again. Okay, and here 2x is x squared plus c. Yeah, get it? Something like this idea. Okay, back to the box table here. 3x cubed plus 5, differentiate, you get 9x squared. So if I want to find the y having the dy dx is 9x squared, what is my then my y will be 3x cubed plus c. Okay, yeah, can so far. Here y is sine x, I differentiate, I get cosine x. Then I reverse the process, I do integration, I get sine x but plus c. So everything is always plus c. So again, differentiate e2x, you get 2e2x. You do the reverse process, you integrate 2e2x, you get e2x plus c. Yeah, so in general, when you do integration, you will have an arbitrary constant all the time, 100%. You'll get an arbitrary constant or a constant. Okay, so I summarized it in the box here. Now, because I'm not seeing you every day, so normally this sort of lesson I will try to just condense it. Okay, so you need to catch the pattern. Okay, so the way of teaching here is different from your school. Yeah. So here, the integral of fx always contains an arbitrary constant c. Okay, and because of the uncertainty, Oh, sorry, wrong spelling. Uncertainty. Okay, because of the uncertainty of the c, we don't know what is the c value. It could be 5, it could be -10, it could be 1, and so on. Then this is known as an indefinite integral. You know, the indefinite means like cannot be determined, cannot be concluded properly. Okay, indefinite integral. Okay, there's no fixed answer to it. Get it? Yeah. So here this is a box. It says differentiate fx is f prime x. Then do the reverse process. I integrate f prime, I get fx plus c. Okay, we move on. Then you find wow like that. Then how to do? Okay, don't worry. We'll skip this part. We go to the theorem. People always ask, can I have an easier way out? Can I do something easier so that I can do the integration properly? Yes, there's a formula to it. This is the general rule. Okay, this rule is very important. It tells us if I integrate x to the power n dx, I will get straight away this answer. Can you check? Yes, I can check. I can take this guy, do a differentiation. If I do a differentiation, do I get xn? Right? Can you bring the power down, n plus 1 will cancel with the n plus 1, you get x to the power n plus 1 minus 1, so you get xn. Okay, do you see? Yeah, so in differentiation, right, you have a rule. Differentiation rule is this. Then integration rule is reverse. You see the reversing process? The reverse process is there's a, instead of times you have divided, instead of minus you have plus. Okay, something like that. So this is actually a integration rule. So it's very important. You need to know this rule. Okay, using this rule, we don't need to crack our brain so much to answer the question. Like what's the reverse process? Okay, so we look at example 2. Simple example first. X to the power 7. How do we integrate? Yeah. According to the rule, it says that I have the power plus 1 divided by the power plus 1. Then plus c. As simple as that. If you apply the rule. Okay, you take the power, you plus 1, divided by the new power. You get the answer. So this answer is 1 over 8 x8 plus c. And let's look at 2b. The catch is you need to bring the power up to the index notation level in the form. Okay, so after that you apply the rule. Take the power plus 1 divided by the new power. Whenever after you've done your integration, you need to plus a c straight away. You cannot delay. Okay, yeah, so the answer is negative 1 over 9 x9 plus c. Get it? Plus c. Plus c. You all do and see whether you can do. I erase. I erase. Then you all do plus c. Yeah, you have to write in the index notation form. Then after that, you do the integration. If you don't write in the index notation form, you will get the wrong answer. So I'll just be careful of it. You get this answer? Okay.
Yeah.
Mm. Yeah, do you notice that the powers, the fraction actually reciprocal because of the divided? Yeah, so it's split. Oh. Okay, so this is 2C. Mm. Then after that, we have some results here. Okay, these results are very important. Not only useful, but they are very important. Okay, I erase the 2C. Okay, engineer. Yeah, so the result, I just prepare you why the results are like this. Is this you remember we differentiate kfx in differentiation, we can bring the k out, and then we differentiate fx no matter what is fx, right? So the same thing here. For integration, we can take the k out, bring out the k, and we can do the integration inside. Okay, then the second one, just like differentiation, we have your rule. If you recall, very long time ago we do all these things, then we can always split it, plus or minus, split it into 2 and do. Okay, so it's the same as integration. They behave the same way. So you can also split the expression and then do the integration. So the split. Okay. Lastly, integrate k, a constant, dx will give you kx plus c. Is that obvious to you? The last point, number 3. Integrate a constant like k, you can actually think of it as k x0 power 0 for the x. Then you can bring the k out due to number 1, the result. Then apply the general rule. Then you get ks plus c. Get it? But you may ask, how come specifically we need to highlight this part? Why this result number 3 is so specific? Okay, the reason is because there are 2 reasons. One is integrating a constant is quite common in problems. Secondly, the k is a bit different from like the x. There's no x term here, so some people find it weird how to integrate it. Okay, so the answer is actually just ks plus c in general. So if you can remember, will be good. Then the rule will speed up your problem solving. Okay, let's look at example 3. Example 3. Try to adapt to it. You all are young people, so these are new things, so adapt to it. Okay, it's a training. In work, unless you are becoming a research in math or teacher in math, you probably won't see integration in your life again. Okay, except if you are doing economics. If you are doing economics next time, you'll see a lot of integration. Yeah. Okay, this one. Okay, so to do the integration, we first write it in the index notation, proper index notation. Then we apply the rule, we can split it. and we also can take out the constant. So far, get it? Is that you split, you take out the half, the multiplier half, so you get this line. Then after that, I can apply the formula. Okay, then plus c. Whenever I do an integration, I'll do a plus c. Then this guy will be 3. This formula 3x plus d. Okay, whenever you do an integration, there will be a birth of a arbitrary constant. So you'll always see an arbitrary constant. So if you integrate something 10 times, you'll see 10 arbitrary constants. Okay, but the answer is, we are going to write the answer in this way. Okay, we are going to combine the two constants because they are just numbers. So we can actually replace it with another general constant. Okay, so this is your plus c. Then normally you'll tell people what is that. So you'll say where, since you are writing it so big, where c is an arbitrary constant. By right, every question we need to write, but this is just a practice. We don't write it. Okay, in your exam, whenever you have a plus c, you better write this statement. If not, your teacher will be very angry, and you may result in the loss of marks. Okay. Yeah. Let's look at part B. Part B. And then I want to tell you something more. Part B. Okay. 3B. Integrate this guy. Write in the proper index notation. Samantha sleeping.
No,
She looks like closing the eyes.
because my eye very small.
Okay, what? Korean stars, their eyes very small. Very good. Very popular. Go Korea next time. Then they have you want the eye bigger? Can, no problem. They can do it for you. Okay, here I'm going to split into two. Okay, so far so good. Can. Yeah, then after that we apply the normal integration rule. This time let me write first, then you see. As expected, we do all these things. Then I stop writing for the c. I put the c at the back. This is allowed. That means even though you integrate 10 times, but you know that every time there's an arbitrary constant. So instead of writing every time a c, you just write a combined c. Can you get it? Yeah, this combined c will just take care of all the c's that you created along the way for your integration. Yeah. So simplifying, you can copy. Then simplifying you.
Why minus 3?
Oh, sorry, my bad. What should it be?
3 over 2x squared.
Sorry, yeah. I thought it's a constant. Is it okay? The rest? X, x the power is 1. So it's 1 plus 1 over 1 plus 1. So after that, thanks. Very alert, Sarah. Okay. Negative half plus 1. So it's half. So I bring it up. And this one is 3 over 2. Let's bring it plus C. Yeah. So this is the part B. So far so good. Can we go to C. I better erase all these things. Okay, go to C. Samantha, okay? You finish copying already, or you're not copying?
No, I copy finish already.
So far.
Wait.
Eh,
Okay, never mind. Never mind.
Never mind. Because there's no
Yeah,
button. I don't know.
I can work it out.
Oh, the final answer, Something like that.
It's okay. I got it.
Check,
Yeah.
final answer. Yeah, because there's no answer here, so I need to make sure you all got the answer. If not, later you get the wrong answer all the time. Okay, this one, last one. Okay, again we are going to split it, and we bring all the multiplier out. You see, I'm condensing some steps, and then bring the index notation. Yeah, so you need your index notation well. You need to know them well, how to convert, and then you need to also incorporate into your integration here. So you have this part here, then we do the integration. 3 over 2 plus 1, 3 over 2 plus 1. Alright, there's a plus C. We will hold on to the last part to add in the plus. And plus C. Okay, then after that, simplify. So make sure you simplify properly. Yeah. Try to, when you do your problem, final answer is always the positive index. So you try to make it positive index.